y1. The x values are the years. This is x2, and this one is x1. So if you remember doing slope, we're doing rise over run, y2 minus y1 over x2 minus x1. And in this case here, your y2 is the 4221. y1 is the 2537. On the bottom, we have 2005 minus 1980. So when you did the number you gave me for D, which was 1684, that's the value for the top of the fraction. Okay, we have to do the bottom of the fraction, which is, looks like 25 years. So we're going to divide that number by 25, and you get 67.36 cars per year. And which number does that stick with?
D.
Not D.
No, C.
That's right, it's C. Okay? So we have to be careful with that, as when we're dealing with that, we can sit there and have those through there. Okay. What's so funny? You have a question? What's up? I can't hear you. What's it? Okay, let's look at number 5 then. To get to work, Truman waited 19 minutes for the bus, then traveled 10 miles on the bus at a speed of 20 miles per hour. How much time passed from the time he left for work to the time he arrived at work? Okay, what do you think? Go ahead. I think it's C. Okay, well, let's take a look. So what we're looking at here, we have to get to work, he waited 19 minutes for the bus, then traveled 10 miles on the bus at 20 miles per hour. So that's 20 miles per hour. Okay. Look at that equation. It looks like a y equals mx plus b. See how that works? So it turns out that time he waited before the bus got there is the y-intercept of your graph. And then, so now we can just try to calculate how much time was left. So if you're looking at traveling 10 miles on the bus at a speed of 20 miles per hour, so here's 10 miles is equal to 20 miles per hour. So if we do that, that's looking like that's half an hour. 0.5 hours for your time. So he has 19 minutes plus 30 minutes. And that is very good job for those of you that said C, because your answer is in fact 49.
Oh yeah.
Okay. Looking at that last one, the altitude of a plane above sea level in feet, m minutes after departure is 293 plus 400 m. So which statement is correct? What did you think? Okay, Dawn, you can do this one. D? Plane's altitude decreases by 400 each minute. Okay. Well, somebody said wrong. Why is that wrong? Because you think it's wrong. Okay, yeah, that's a good reason, right? Maddie, help us out. What's going on here?
I said it was B, and D was wrong because it never said it would decrease after departure.
I agree. Okay, so here's why. Look at that statement. 293 plus 400 m. Since that's plus 400 m, what that means is that that plane is getting higher. How many of you have ever flown on a plane? Okay, well, if you've flown on a plane, you know how that works then, right? You take off, and the first few minutes after takeoff, you're still going up. Okay, so that experience matches the information here. The correct answer is B, by the way. It does increase, and it increases 400 feet for every minute after takeoff. At some point, though, it's going to have to come back down. But that's not covered in that problem. Any questions on any of those that we that did here? Okay. Well, let's look at this first paper that's here. Okay. Find the value of r so that the line through point 14 and negative 5r has a slope of 1 over 3. Okay. Couple ways we could do this, just so you understand what's happening here. I'm going to try to draw it real quick as best I can. So if I'm trying to draw a graph just to illustrate what's going on, the line through point 14. So 14, I go, here's my origin. I go 1 to the right and then up 4. 1, 2, 3, 4. Okay? So there's my point 14. Okay? Now, I need a point that goes through negative 5 and r. So negative 5 is 1, 2, 3, 4, 5 to the left. So somewhere on this line right here, my line's going to intersect it. And I need to know what point. Okay? Now, visually, you could do this in such a way that we are doing... I have a slope of 1 over 3. Remember, rise over run is the 1 is your rise and 3 is your run. But we could also do that where both are negative. So we'd have a negative 1 and a negative 3. So you could count back. We're going to drop down 1 and go 1, 2, 3. So your next point would be like right there. Then we're going to drop down 1 and go 1, 2, 3 over. And there it is. Okay, do you see how you could do that? This is negative 5r over here. Okay, so one of the things you could do is do it on a graph. Okay, that might be easy to visualize, but it's going to take you a long time to do that if you did that for every problem. Okay, so that's going to be down 1 over 3, down a second one. So you're looking at 2. So it's going to be at negative 5 and 2. Okay? So that's where it's going to be. But now we're looking to see, is there a way we can do this algebraically where we don't have to always draw the graph and then count over? Okay? So we could start with an equation that looks like this. I know you've seen this equation a bunch. There's y equals mx plus b. Okay. So somebody's lighting your phone up with messages, aren't they? Now, okay, I can plug in some things that I know here. Out of y equals mx plus b, what do I know? Yes, Maddie? Very good. So one of the things I can do is write it like this, where I have 1 over 3 times x plus b. Okay? So that's a good start. Okay? The next thing, is there anything else that I know here? Well, of the other things that I know with this, okay, if you look at that, one of the things that I know is that I have here, I was looking for a different pen that might have a different color I could use for this. Yeah, I'll try that. Don't I also know this point right here? 1 is x and 4 is y, isn't it? So what if I put that in this equation as well, where I do 4 here equals 1 over 3 times 1, and then I have plus b. Okay? By doing that, you see I now have an equation where I can solve for b. Okay? And doing that allows me, I have 4 equals 1/3 plus b. So this is one way I can do this. All right, and then I could just subtract. So 4 minus 1/3 is your y-intercept, so that would be 3 2/3. Okay. I don't like the way that's working here, so let me just double check this as to how to get there. Because that's going to be... It does match my y-intercept, but you're... so I can then go back into this and do y equals mx plus b. Now look what I can do. Okay? Look at my unknown point. I have an x, but I don't know y there, do I? So what if I take this number I just found for b and plug it in right here? So that would be 3 2/3. Okay? And now I have an x, so I can put the x with my slope. My slope is still 1/3. My x is now -5. And now I can get a number for y. Okay? So that means y equals -5/3 plus 3 2/3. And I can do y equals -5/3 plus 3. They can make that as 11/3. What's 11 plus -5 here? Anybody know? Go ahead, Tom. Not -16. Because notice the 11/3 is not negative. Go ahead, Maddie. What you got? Not 7. What is it, Tom? It's 6.
Oh my gosh!
So y equals 6/3. What's another number that looks like 6/3? Go ahead, Dawn. Yeah. It's 2. So look at 2. Y equals 2. And guess what? Look what we said the answer was over here. There it is. -5/2. All right. So there's 2 ways I showed you can do that. One with the graph, one with this. So let's see. And let's see what I got here. Let's take a look at that next one down here, where you have find the value of r for the line through -2 and 6, and r minus 4 has a slope of 5. Okay, so we can try to see what that does for us. All right. So once again, if I wanted to draw a quick graph, I can do that. I've got 6 and 4, so I want to have at least 6 places here. All right, so if I put my first point, -2, and all the way up to 6, there's my first point. There's -2 and 6. Okay, so now I want to know what point goes through r and -4 that has a slope of 5. So I could come down here and do 1, 2, 3, 4. Here's -4, so somewhere along this line here, I'm going to have a line that goes through this. Okay? But look at my slope. My slope is 5. So I have a rise over run of 5, or 5/1. And it could also be a rise over run of -5/-1. So what I would do, I could drop down 5 spaces and then move left 1. There's 1, 2, 3, 4, 5, and then move left 1. That would be right there. I could do that again. There's 1, 2, 3, 4, 5, and then left 1. That would be right here. And all of a sudden, you see a line that pops up that goes right there, and it goes through my points. So I could look for this point right here, which looks like it's going to be 1, 2, 3, 4, -4, and then also at -4. So that's the point I'm expecting. Let's see if we can do that using our equations. All right, Nevaeh, why don't you help us out here? If I start with y equals mx plus b, what of that information is already given to me in this problem here? Which number? The 5, okay. And where does that go in this equation?
It goes, B?
No, b is the y-intercept. All right, Sierra, since you're laughing too, where does that 5 go? If it's not b, what does it have to? Where does it have to go?
M.
It is m. So there is 5x plus b. Okay. What else do I know? Please make sure the masks are on, sit up, and please pay attention to how this is done so that you know how to do this for your homework assignment. We know x. We need x, don't we? But what about the point that we do know? Go ahead, Landon, what you got? Well, how did you find that? B is not the slope. B is your y-intercept. Look at your y-intercept here. It's hard to see, isn't it? It's probably going to be up here somewhere. Okay? Again, look at our point right here. There's your point, there's your x, and there's a y, right? What if we plug that into this equation for x and y? Think that would work? Sure, because it did up here. So here is 6. Here is -2. All right, so I have 6 equals 5 times -2 plus b. Now you can solve for b. 6. What's 5 times -2? Please turn that off. You're in class right now. Okay. Oh, go ahead, no, sorry. It's -10. Okay, and now we just have to solve for b. What number is b? All right, Dom, go ahead. Not -4, because look, we're going to add 10 to both sides, aren't we? 6 plus 10 is what? Very good. So your y-intercept is 16, which, like I said, that's going to be way up here, isn't it? Off of our graph. Okay? But now that we know what b is, we can go back into this same equation. And let's put 16 in for b. Our slope is 5. X is our unknown. We'll use r there, right? And then y is going to be -4. Here's x and here's y. So y is going to be -4. So now all you have to do is solve that equation for r. What's the first step I'm going to do there? How you doing with this, Abby? What do you think? Okay, so what's the first thing I'm going to do? Yeah, we're going to take that 16 and subtract it from both sides. Okay? What is -4 minus 16? Anybody know? Go ahead, Don. Not 12. Maddie? It's negative 20. We're adding those together. So since they're both negative, it's going to be negative 20. Now we just solve for r. So we're going to divide both sides by 5. And that tells us that r is equal to what? Go ahead, Dom. Thank you. Negative 4. Okay, it's negative 4. And lo and behold, look over here. Didn't we say it was negative 4? So that matches what we expected from our graph. Okay? Are you guys getting comfortable with this at all? I'm going to give you your... I'm going to give you the... yeah, and then we're going to go ahead and I'll try to do one with you because we're starting to run out of time. So I got to give it to you. Okay, here's this. Let's see here. Let's see here. Let's put it in.
Oh, I can do this. No.
You got 2 because one's for a brother. Yours. One for you. This is the homework. Let me take a quick look and I'll tell you. All right. Let's do, we can do slope already. We should be able to do all of these. I want to concentrate on 10 through 15 right now because guess what? Finding the slope of the line, you know how to do that, right? Okay, we could do one of those to practice, but what we did today are numbers 10, 11, 12, 13, and 14. So let's take a look at one of those to make sure that we know how to do that. Yes. Yeah, that's going to be our thing. So we have a. I'll show you this little shortcut. We should be able to do the whole thing. You guys can do slope. So let's look real quick at one of these right now. I'm going to even show you another short way you can do this. Which one? Let's look at number 12. Okay. So if we look at number 12, find the value of r so that the line through r negative 4 and 2, 8, okay, has the given slope. So I know what my slope is, right? So if I look at my slope, here's another way I can do it. Instead of doing those double equations like I did, what if I use the equation for slope? y2 minus y1 equals x2 minus x1, right? That's rise over run. Well, look at this. This one will be even easier for you. What if I do this? y2, x2, y1, x1. Does that make sense so far? Now I'm just going to plug these numbers in. y2 is negative 4. y1 is 8. x2 is r, and then x1 is 2. M is negative 3. So now I have this equation here, right? I need to then divide or multiply by everything on the bottom. So if I multiply by this parentheses here, I can do r minus 2 and do r minus 2 here. It'll cancel out on this part, and I'll have negative 4 minus 8 equals negative 3 times r minus 2. Okay? What is negative 4 minus 8? Go ahead, Don. It is negative 12. Now let's distribute here. What's negative 3 times r? Very good. What's negative 3 times negative 2? Right, so that's going to be positive 6. Now we just have to solve this equation for r. Subtract 6 from both sides. Negative 18 equals negative 3r. Divide by negative 3. And what I get is positive 6 equals r. So whatever way you want, if you want to do it this way, that's fine. If you wanted to do it the other way I showed you, that's good too. Okay, this might be quicker, but both ways work equally.